This is the first video for Unit 3. In Unit 3, we are talking about Newton's laws of motion. In Units 1 and 2, we studied the how of physics. This is known as the kinematics. So this would involve things like how fast, how far, how long, how high, how much time, how quickly. In Unit 3, we start studying the why of motion, which is called dynamics. Why is it at rest? Why is it in uniform motion? Why is it accelerating? To very simply explain why an object which was once at rest is now moving, we use the word force, which very simply may be defined as a push or a pull. Force is a vector, meaning it has both magnitude, which is size, and direction. We've already studied two other vector quantities. One was velocity, like 50 miles per hour to the east, as a magnitude and a direction. Or acceleration, like 10 meters per second squared down. Before we get to Newton's laws, we need to equip ourselves with some math skills concerning vectors. A vector quantity is represented by a ray. The length of the ray indicates the magnitude, and the direction of the ray indicates the direction of the vector. So let's draw rays to represent forces. 5 units north. Something like this. This is my ray. It indicates the direction. It also indicates size, which we wrote off to the side. Now in this next one, 2 units east, and we're using map coordinates, so we're talking about like a map. So 2 units east might start here and go about this far. If you compare your rays here, these should be relatively proportional in size. Now it's just a rough sketch, but if this was 2 units, this should be 5 units, maybe a 2 being here, and another 2, and then the last. So these should roughly indicate the size. 10 units, 50 degrees north of east. So for this one, let's draw a basic coordinate grid. So it's going to be 10 units long. It's going to be 50 degrees north of east. So this is the east line. This is the north. So this would be directly east. This might be 45 degrees north of east. And so we're talking about maybe something like this, where this is 50 degrees and this is 10 units. We're not really using rulers here, so our vectors represented as rays are going to be rough sketches. Draw rays to represent velocities of 80 meters per second west. So west is this direction, and we'll say this is 80 meters per second. The next one, 100 meters per second at 50 degrees. So let's draw a little grid. So this one is slightly different. So we have to use the appropriate degrees, and like in math, 0 begins here. This would be 90 degrees. Here is 180 degrees and 270 degrees. 100 meters per second at 50 degrees. So here's 0, 50 would be approximately here. And we are going for 100 meters per second. So slightly longer than the arrow for 80. So here's 100 meters per second, and there's 50 degrees. So really there's a couple of different ways that we could indicate the direction of these vectors. Adding vectors. When we draw diagrams to represent addition of vectors, we can use one of two methods. The first one, the head to tail method. Place the tail of vector 2 at the head of vector 1. The sum, or what we call the resultant, is the vector that begins at the tail of vector 1 and ends at the head of vector 2. So let's give this a try. So let's call this vector 1 for now, and this one vector 2. So the head to tail method says that we are going to take this ray and we are going to put it here. So you take the tail of vector 2, that was here, to the head of vector 1, and the sum is the vector that begins at the tail of vector 1 here and ends at the head of vector 2 here. And so I'm not using a ruler, I'm going to do my best here. Nope. One more try. There we go. And this is going to be labeled the sum. Now, does it matter which one we call number 1 and which one we call number 2? So let's do this one. Let's move vector 1 down to here. So let's try this. There's vector 1. A little bit too long. Okay. So the sum in this case is going to start here and end here. And so what we find is the same resultant vector when the two are added either way. We'll make a note of that here. Same resultant vector In number 2, we have 2 vectors and they share a tail. That they go off in different directions and they have different magnitudes. So let's call these number 1 and number 2. We are going to take vector 2 and place the tail at the head of vector 1. So right here, there's vector 2. And the sum, or the resultant vector, would start at the tail of number 1 and end at the head of number 2. There's our sum. This also works when we have more than 2 vectors. So we'll call this vector 1, this one 2, and this one 3. So using the head to tail method, let's go ahead and move vector 2 right here. There's number 2. And number 3 we will move right here. And the sum, or the resultant vector, would begin at the tail of number 1 and end at the head of number 3. And there is our sum, our resultant vector. There is a second method. This one is called the parallelogram method. Place the 2 tails of the 2 vectors at the same point. Form a parallelogram with these 2 vectors as 2 adjacent sides. The sum, or resultant vector, is the diagonal of the parallelogram drawn from that point. So here's what we're going to do. We're going to take this vector and put it right here. They need to place the tails of the 2 vectors at the same point. So then what we're going to do is draw a parallelogram. I'm going to use a dotted line. So this is very approximately the length of this vector. And then here. And this is approximately the length and direction of the other vector. The sum is the diagonal of the parallelogram drawn from where the tails are. So the sum is going to go this way. For number 2, the 2 already have tails at the same point. So we don't have to move one. We just need to go ahead and draw our parallelogram. So here's a dotted line. That's approximately the length of the other one. And then the diagonal, starting where the tails meet, is the resultant vector. That is the sum. Example number 3, parallelogram method. How do we make a parallelogram with 6 sides? Here's what's going to happen. This one is not going to work with the parallelogram method. Use the head to tail method. Adding forces. The unit we use for force for now is the American unit. The American unit for force is the pound. So adding forces, we have 50 pounds east and 60 pounds east. So let's draw some vectors. So here is 50 pounds, and this one is 60 pounds. And the total, or the resultant vector, would start here and go to here. We are adding them together. 110 pounds to the east. But the next one, 50 pounds to the east and 60 pounds to the west. So here's our starting point. 50 pounds to the east and 60 pounds to the west. In this case, the resultant vector is 10 pounds to the west. Looking at this one, a good way to think of this is a game of tug of war. We have 60 pounds pulling to the west, 50 pounds pulling to the east. Which one wins? It's the one that pulls harder.